This is me. Took it right now. I've been working with web development since the mid-90s. Started just when JavaScript was new and Java was new and everything. So it's been a long, fun journey. Today I work as a consultant for hire, usually at large enterprises. I'm also the group leader for this company, which is Inmeta Consulting. It's a large-ish consulting company. It's large for Norway. It's not globally large. Which is a very nice company with lots of fun people, lots of JavaScript people, lots of Java people, and .NET people, and designers. Also, I need to plug this one because I just wrote this. This teaches you everything about React, about Browserify, Webpack, NPM, how to get started with React, and how to build applications. The example I will talk about a little later in this talk is lifted from chapter 9 of this book. So I will make the code available, and if you want to delve really further, you can look at the book. All right, let's talk about server-rendered apps. Yeah. So that's a cool topic. You may know this as isomorphic, which is a really fun term that I think some guy in Airbnb developed. Probably some maths guy, really fun guy, I think. Because when I looked up isomorphic in the definitions, it said an isomorphism is something between two combinatorial objects is a map that preserves sets and relations among elements. And secondly, it was also an isomorphism is a collection of objects that's isomorphic to each other. So that's really mathsy and not really programmerish. It's like, it doesn't mean anything. It means that something is equivalent to something else. So the only good thing about it is it's very easy to search in GitHub and find someone else is writing something isomorphic because that's what it is. But some other guy, some React guy, actually I know who it is. It's Michael Jackson, the singer. He doesn't like that. But anyway, he coined this term, universal. The problem with universal term is that it means different things for different people. For the Meteor framework, it means sharing code between server and client. It doesn't mean server-ended code. For some other guys, it means server-ended code. And so I'm looking up universal code on anywhere is like super problematic because you don't know what you get. So I think this term is also problematic. So what is it really then? Let's think about what is a server-ended app. It's about sharing code between your server code, and your browser code. And you want to write this together and share the code. You don't want to write one separate piece of code for your browser and then separate piece of code for the server. It's also about delivering content faster. And you might as well just call it writing shared code. But I feel server-ended is kind of correct. So server-ended shared code. And I don't know, we need to find some acronym for that or something. I haven't done that. So there's also one more thing about server-ended code. We will get to that now. So server-ended apps, a little bit of history. In the past, we usually made apps with the backend languages and a template engine. Like in React, they threw away templates and put JavaScript first. With PHP, which I did for many years, we used something like Smarty, we used Twig, stuff like that. In Java, you used JSP and Timeleaf, and then we used that myself. I've seen lots of people have used it. And also in JavaScript, before React, we used something called Express, not Express, but Swig, and EJS, and stuff like that. But what about React? How does this fit in? Because in React, we don't want to use templates, and I'm not arguing that we're going to go back to using templates. But this is kind of true, because we have stuff that works. You can use our backend language, you can write templates, and you can have server rendering for free. But now we're going to use React, and we're going to use everything on the client side, and we still want server rendering. So why do you want to use server rendering? And this is a question that will answer that. Because when does a user leave a site before it's loaded? And the answer is, what do you think? If you go, yeah, right, it's too slow. The page is just too slow. And that happens a lot. There's been lots of studies related to that, because page load is really critical. Amazon did a very famous study. They said that every 100 milliseconds of latency cost them 1% in sales. And that's, for Amazon, that's an incredibly large amount of money. Another study I read, 47% of users expected the page to load in less than 2 seconds. And 57% said they'd leave the site totally if it took more than 3 seconds to load. So when is JavaScript slow? I'm going to really hammer down some really solid reasons to why client rendering is slow. And it's slow when the user is on a slow computer. Well, obviously. It's a funny thing. As developers, we all have super fast computers. But the users don't have fast computers. Many times. Many times they have really old computers running Windows 98 or something. I hope not. Or if the user has a slow connection. The initial load of a client website application is really, really slow compared to server-rendered apps. A group called the Filament Group released a study said that the average initial load page time for Angular apps is 3 to 4 seconds. And it goes up from there. They did some said that React was kind of 1 to 2 seconds. But then you throw the API calls on top of that, so it feels even slower. Or the user is on a slow smartphone or tablet. Again, we're all having the fastest iPhones or the fastest Samsungs or something like that. But most users have slower phones, so they don't switch them out, and then they use super crappy tablets. This goes back to the slow computers again. If the user is stuck on a computer they don't control, like in a library, in a school, they're really stuck. That makes our page run slowly, because when they get the JavaScript and they need to compile it, it takes time. Okay, the user is trying to download your site to read away from the internet connection. Can't do that with a client-rendered app. No way. And if that someone is Google or Internet Archive or maybe some other search engine in the Western world, it's probably just Google. But you know, in Russia they have some other crawler that's very popular, and probably India and in China too. And I can't read this. And in Google's own words, there's no. This is Google's own words in a study in a document they released. There is no success story out there for a client-side only web app that beats server-rendered websites for competitive keyword searches. Think major purchase items like flat screen TV or best car 2015. Again, if the user has NoScript, like a crawler, and the users may have that because they don't want ads. And again, if they have ads and you name your critical JS bundle something related to ads, and that you may do this because you have a user in a different country who thinks of ads like something like some word that doesn't relate to ads for you, but it is to them. But there's some good news. All of these problems can be solved with server rendering. Rendering your content before you serve them makes Google happy, slow computers happy, smartphones happy, and NoScript happy. But best of all, it makes you happy. Really does. So yeah, again, let's make it happen. First, some goals. You want to write code that you can use everywhere. You want to render your app so your client doesn't have to. And then you want the dynamic bundle to take over once you have presented the app because you want interactivity. And this is the behavior we want. Let's see if this starts. Does it play? I think it does. Okay. So this, you'll notice that this site is now server rendered. You see, I open the console. I turn off JavaScript. I can browse the app. I click on it. Everything works beautifully. It doesn't need JavaScript. And when I go to a site like this browse CEO, which will tell me everything about my app, it will render the contents of my app. It will show me how many links I have, and it will give me statistics. If I have a client-rendered web app, it will show nothing. It will show a blank page, like Google says. So you made a beautiful client-rendered app, and Google, you tell Google about it, and they come along and say, "What a nice app! Hey, there's nothing here." Well, with server rendering, that don't happen. So let's look at what you're gonna do. Let's delve into some code. First of all, I've only done this with a Node Express server. You can probably do this in some other language too. But I found now Node Express to be perfect because it's really the great symbiosis between writing JavaScript code and use it everywhere. This is a very simple Node Express server, the one I used for the previous screen. In this one, I will start by importing my routes. I will fetch them exactly as they appear in the client-rendered app. In this example, I'm using Redux. It doesn't really matter which Flux library you're using. I'm not using Flux at all. It doesn't matter at all. I'm just going to use it here because that's what I did. And then you're going to import your API methods. This is my fetch post async code. I'm going to use it, and I'm putting all my fetch posts, all my fetch code in a shared folder. So I'm putting it in source shared and everything there. So I know that semantically this is a shared code snippet. And then I'm going to start this bit. When I go to a route, or the user goes to a route, this will match the imported routes. Then I will build up my state. After the fetch post async is complete, it will populate all the state I need. It will put all the posts in there and give you some information on when it was last updated. Then it will create an HTML version of your component with state. Now this is using React DOM server rendered to string. What that does is take the entire application and put it in the store, put your state in the store, and put the whole route in context and make a huge string out of it. Then I will start sending this to the browser. I'm using the Express send. I will build up my HTML in the as a template, as a literal string. This is, I showed this to my Java group, and they freaked out because why this is a method to put a large string of HTML inside my server and just build it up. Personally, I think this is a good way to do it, but you can also extract it to a single file and then import it and then shove in the variables like we're all taught to do. Here's my state. I will inline the state inside the after the head and before the body. So this initial state, window.initial state, will be available to me in my client code. And what I'll do is, in my client code, I will look for this variable, see if it's present, and then repopulate. I think Yahoo used the word like rehydrate their stores, by just fetching the state that comes from this little snippet. Next, I put in the app content. This is the rendered to string bit from the previous page. And also I'm using the source bundle.js so I can get some interactivity. So I wish I could see that now. Okay. So advantages to this. This is awesome because this gives you less work on the client. That means faster rendering. Reuse code from the front end. Again, one of our stated goals. And the app works even if your JS bundle breaks. So even if your bundle is gone, maybe you put it on CDN and the CDN doesn't respond, the app still works. Or if you introduced a little syntax error and you pushed it up, doesn't matter, as long as you didn't put that syntax error also in the server edit code. There are some disadvantages to this. And one more advantage. If the user has NoScript, they will still be able to view your page. And then another advantage, if it's a bot, like Google and Internet Archive. So, let's talk about the drawbacks. You need to write a complex server file. The server file becomes rather heavy. And this example I had was just one single fetch and fetch the posts, and I populated my store. If you have more pages, you need to put more logic inside your server, and it will build up, and you will have to do a lot of work there. And then you may have to do some of that work also in the client. So you need to do lots more work than you're doing now. That makes it so that you need to do this consciously before you start. You can't write an app and spend 6 months writing a browser-rendered app and then say, oh, no, I want server rendering. You need to do this immediately and start in the same time as you start writing your app. And you need to rely on this fetch method before render, of course. And that's a problem, because if you write your code so that you need to fetch a lot of data before you render, you have just offset your slowness time to the server, and then the users will still have to wait because they're still fetching, and you have a blank page, and then suddenly everything pops up. And it's pretty slow, again, because there are no optimizations. When we had templates, we could hard cache everything and just show it out there. But with render to string, you need to have React go through the entire app, fetch the data, concatenate the HTML, then put it all together, and then put it out there. And I haven't found a good way to cache that. You need to cache you can cache the API data so that is fast, but you still have to wait and hope that React doesn't take too long. So that is a problem, and that is actually solvable, fortunately, at least a little bit, because you can add streaming, which is super advantageous. Instead of using React render to string, you can use a library called React DOM stream. I heard about this in, I forgot to look up the name now. But there was some guy in doing a talk in San Francisco who made this one, and he put up a lot of data showing how fast it can be to stream your content instead of rendering it to a single string. And what you do is you take away the render to string bit, you take away the app that you put in, and instead you do this. Instead of, previously we had rest.send, we dropped that and we put in rest.write instead. That means that the Express server will start writing to the browser immediately, and we'll send the entire HTML up until just above the marked segment here. They will stop just after the body and the div ID equals app. Then we'll start with the const stream, and then we'll start rendering the string with the streaming. And the benefit of this is that as the data flows into your app, it will write it out to the browser immediately. You don't have to wait until everything is finished. And this is a huge boon if you're fetching a lot of data, because you can simply keep streaming. And then finally, we when the pipe is there's nothing else to stream. It will stop streaming, and then we'll just write the closing tag and include the bundle again. So the main change is this bit is that you stream to the render string, kind of stream to the render string method instead of sending the pre-generated app variable. So that's actually it. I have some resources that I would like to talk about. I put up the first link is the best way to learn about writing isomorphic apps. Now I'm back to that that term, because that's easy to search for. So this first link is just a GitHub search to isomorphic apps. You can find lots of different solutions. There's also an out-of-the-box solution called Flexible. I think that was written by Yahoo. That means you don't have to do as much code. You can get a lot of stuff for free and avoid writing all this Node Express stuff yourself. I haven't actually used it.
Oh, hello.
Okay. Well, you probably heard the last bit anyway. Flexible. Come with high regards. And then, I'm sorry, but my book is just, I spent a year and a half writing it. It's finally coming out. And I was told that I was going to need to tell everyone that you need to tweet at conference. I know people have done it, and really like to see what you guys said. So I hope you liked it, and if you have any questions, I'm